Hello! In the following, I will briefly present our prototype solution for the Designing Interactive Systems course 2023 at the KIT in cooperation with EnBW. Our focus lay on supporting the customer service agent instead of replacing them. This is reflected in the functionality of this prototype. I will briefly go over the main structure and explain the gimmicks that we came up with to support the uses of the system. As you can see, the prototype is sort of split into two halves. The left side of the screen is occupied by what is currently called RC at EnBW. This system manages the ticket system as well as calls and caller data. The right side is the main part of the system, where changes to customer and contract data can be undertaken and which is currently mainly done by a system called ThinkOwl at EnBW. The first frame presents a general overview of an agent answering an email. The first step an agent usually takes to classify the incident is to identify the intent. For example, if the customer is writing to resolve a contractual issue or because they want to end their contract. The email history is provided to a large language model to which I will refer in the following as GPT. GPT is able to identify the intent from the conversation as well as provide a handy summary and propose some next steps. As you can see, all screen elements the GPT influences are highlighted by a purple border. This serves as a quick and easy recognition for the agent. Here you can, for example, see that GPT proposes the incident to be classified as a contract and charge issue. However, since it is only meant to support the service agent, GPT can actually not make any decisions by itself. Instead, the agent can always overrule GPT's assessment and classify, for example, this issue as one of termination. GPT still advises the classification as the former, but is overruled by the agent's judgment. Upon answering the email, the agent has the choice to let GPT provide an automatically generated draft. This is tailored to the email's history in question by, for example, already naming the customer and providing answers to their questions or the incident. However, here too, the agent can still change and edit the draft in order to not rely completely on the generated content, but it will save a lot of time and effort on the agent's side. The next incident presents an example of an agent answering a call. Again, the agent can classify the ticket by the intent, and the call is recorded via a speech-to-text software and fed into GPT. GPT then provides a live transcript summary, which updates dynamically during the call and also provides some proposed next steps. The window seen is in fact an actual overview of what the customer data portal looks like at EnBW. With the amount of menus and tabs, a human can quickly become overwhelmed, especially if they are new or not that well trained. While all customer service agents are very well trained to use the system, complex problems can be hard to solve in an equally as complex system. Here GPT helps by providing suggestions for potential menus, for example, to open or data to change. In this example, where the customer calls because of discrepancies in their bill, GPT suggests opening the tab for the bills and checking whether these discrepancies were due to a guess taken by EnBW and their energy consumption, which happens if a customer does not submit their energy consumption to EnBW. Again, the agent can choose to ignore GPT's suggestion, but can just as well choose to follow the advice and solve the problem this way. As you can see in this example, GPT's hunch was correct and the problem was correctly solved. This concludes the presentation of our prototype.